we have an application problem. This is a mass spring system with the external force. So first the equation will be the mass times the second derivative plus the damping constant, damping factor I should say, and then the spring constant equal to the external force. In this case, I'll just write F of t for now. Right. Notice that this is the mass and not the weight. The problem we are given 96 pounds. That is the weight, not the mass. So we're going to use this constant acceleration due to gravity. So we're going to have mass is equal to 96 divided by 32. So that gives us 3. The unit for mass is the slug. I mean, it's not important. So it's going to be 3. So we put everything into the equation that we have. So we should have 3 second derivative. And the damping constant is also 3 plus the spring constant. The damping factor is 3 and the spring constant is 20. Input function external force 3 cosine of 5t. So that is the equation. Yeah. So to solve this non-homogeneous equation, first we'll find the homogeneous solution. We will have the auxiliary equation is r squared plus 3r squared, sorry, plus 3r plus 20 equal to 0. And we solve for r quadratic formula minus 3 plus or minus 3 squared minus 4 3 times 20 over 2 times 3. So at negative 3, that's 9 minus 12 to 40 is negative 231 over 6. All right. Let's split it up in the real part and imaginary part. Right. And for complex solution, we can write the homogeneous solution is C1 e to negative 1/2 t, let's say t over 2 cosine of square root of 231 over 6 t plus C2 e to negative t over 2 sine of square 231 over 6t. Right. Now, note that the problem did not ask us for the solution. The question asks us for a particular the steady state solution. So in that case, let's focus on that. Steady state solution. First, we have this homogeneous solution, and now focus on the e to the negative t over 2. As t goes to infinity, uh, the e to negative t over 2 goes to 0. So this solution goes to 0. So that is called a transient solution, which is not a steady state solution. So we see that in this case, this solution go to 0. So the steady state solution does not include the homogeneous solution. So what we do is just find the particular solution for this problem, and if it is stable, and then that will be the steady state solution. So next, particular solution. We will use undetermined coefficient method to solve for this, because variation of parameters y1, y2 are too complicated to use variation of parameters. So first, the guessing solution will be in the form of a cosine 5t plus b sine of 5t. We can take derivatives and second derivative. Derivative is derivative of cosine is negative sine, negative 5a sine of 5t plus 5b cosine of 5t. Then take the derivative again. Negative 25a sine of 5t minus 25b derivative of cosine is negative sine. What do you have? Negative. All right, and we substitute this into this equation. The equation is second derivative plus 3 derivative 20 times the function equal 3 cosine of 5t. Right. First, we have 3 times the second derivative. The second derivative is this. So we multiply everything by 3. So we have negative 75 a sine of 5t and 3 times negative 25, again negative 75b sorry, the derivative of sine is cosine. Sorry, this copy is wrong. Negative 75a cosine of 5t minus 75b sine of 5t. Right. Next, we have the derivative, which is this, and we multiply everything by 3. So multiply by 3, we have negative 15a sine of 5t. Let's put the 5 here, put the sign here. Negative 15a sine of 5t. And then multiply by 3. So we have 15b cosine of 5t. And then the function. Multiply by 20. So we're going to have 20a cosine of 5t plus 20b sine of 5t. So I put all the cosine one column and every sine over one column. It will be very easy to add them up. So when we do that, we have negative 75 plus 20, so it's going to be 55 negative 55a plus 15b cosine 5t plus negative 55. I should put a and b in alphabetical order so the equation will be very easier to solve. Plus negative 15a minus 55b sine of 5t. This will be equal to 3 cosine of 5t. And then matching the coefficient, we will match the coefficient of cosine 5t with that. So we have negative 55a plus 15b equal to 3. And then we will match this to 0 because we do not have sine of 5t. Negative 15a minus 55b equal to 0. This system of equation, let's just use the calculator to solve for it. First, I'm going to store the values into the matrix. I just put that anything like, let's say it C. 2 by 3. Coefficient is negative 55, 15, and 3. Negative 15, negative 55, and 0. Right, so we have the matrix C. After that, we will do the reduced row echelon form. So second, this button, and go to Math, option RREF, and apply that to the matrix C. Right, so that's what we have. Let's convert this to fraction. So that's what we have. So solving this system of equation give us A equal to negative 33 over 650 and B is equal to 9 over 650. And so the solution, the particular solution we will have is negative 33 over 650 cosine of, we don't need the calculator anymore, cosine of 5t plus 9 over 650 sine of 5t. And as t goes to infinity, cosine and sine are still a sine, a wave, a sine wave function, so it does not vanish. And so that is the particular solution, and it's also the steady state solution.